Hi, I'm recording this video to explain the honors program that is beginning now here at the Selwyn School. Some weeks ago, I was asked about um, my thoughts of having an honors program here. Really, by popular demand, the students were interested in having that offering here. And I was asked what were my thoughts about that. I was eager to come up with something. I think that'd be great. And so I've been thinking a lot about and working on what that should look like and what I would believe would be a good program. So I'd like to explain what I've come up with and why I believe in it. So I first want to talk about what it's not going to be. So let me talk for a second about what math education in the United States looks like in most places today. Um, it is jam-packed with topics. There is an expectation for students going into technical fields that they will be familiar with a great many topics. And there really isn't a lot of room, given the time that we have, to add additional topics. So that's not what we're looking to do. Likewise, there isn't much slack in terms of the pacing of our curriculum to just speed things up. It does take time to learn things, and the pacing is already steady enough. Uh, the idea of going faster or covering more topics, more topics from the books, is not what we're going for. What we're really looking for is how do we elevate the level of thinking and empower our students in their lives after high school. We want more creative thinking and more critical thinking. So to say a little bit more about what the current state of math education is and what a math course is. So for instance, the courses that you guys are in now. There's some fair criticisms that we can levy on that. So for instance, really with math, the subject, there's two components of what we need you to learn. There is two types of knowledge, I should say. There is know-how, one type of knowledge, and know that. There's different names for those components, but I'll go with those for now. We need you to know that certain propositions are true. So for instance, I need you guys to know the Pythagorean theorem that a squared plus b squared equals c squared. I need you to know that the sum of the exterior angles of any polygon is 360 degrees. There are things that you need to know, and we can refer to that as know that type of knowledge. This type of knowledge is easy to write down, it's easy to say, and easy to hear and understand, and therefore it's easy to communicate and transfer from one person to another. In addition to that, however, in mathematics, there is a skill-based knowledge. You need to develop skills through acquaintance with working on things. This we might refer to as know-how. So even though you know the Pythagorean theorem, even though you know that a squared plus b squared equals c squared, if I tell you the length of two legs of a right triangle, do you know how to find the length of the hypotenuse? Do you know how to prime factorize a number? Do you know how to simplify a radical? So we have these two components. One is propositional, made of statements which are true that we need you to know. And the other is skills. Do you have the skills? Do you have the experience? And so that's your normal course work in whatever course that you're in. We're focusing on those two components. Unfortunately, because performing these calculations in whatever course that you're in is so time consuming, the courses end up, the whole curriculum ends up being organized based on the nature of the calculations. So it's really sequenced in a way based on you being able to perform those calculations largely by hand. So, for instance, reducing matrices or factorizing polynomials. The way we organize our courses is really to make sure that you are able to perform these calculations. You could call it a mechanic-centric organizational scheme or focus. And what I would like to do with this honors program is something different, because mathematics is more than performing calculations. And doing harder calculations is actually something that it's often better to avoid. So what this program ought to be, and what I believe it will be, is a problem-centric formulation. We're going to focus on problems that are interesting, that are not so small and distant from life, but more interesting to the student. In the real world itself is in dire need of mathematics. If you ask any employer, they need people with more math ability, more math knowledge. The world is an increasingly quantitative place. There's tremendous amounts of data. There's all sorts of technology. There's a huge need for technical jobs. And if you look to mathematics in industry, in science, and in the world, in large businesses, and what that looks like, and compare it to what we do in the classroom, what math education looks like, you'll notice a great disparity, a great difference in what those two things look like. We have these two worlds of math, and they don't look the same. In school, we have small problems, easy to digest explanations, streamlined explanations, simple numbers to work with, and a focus on performing calculations by hand. So really a sequencing and an organization based on the nature of all these methods of calculation. In the real world, mathematics is all about solving problems. It's all about modeling, simulation, analyzing your results, and critiquing them in the context of the problems that you're trying to solve. And so with our honors program, we're really trying to elevate the whole thinking of our students and focus on problems, not topics, as the curriculum is normally structured by. The book that I've selected that we'll use as our primary resource for the honors course will be the same regardless of the math class that you're in. That's because, again, we're not focusing on the topics that we cover. We're focusing on the problems and the type of thinking that you need to solve problems, open-ended problems. There is no list of topics that we have to cover. This program is sort of supplementing whatever class that you're in. In this supplemental program, there's no specific topics that we have to cover. We're in no rush to make sure, we gotta get to the end of the book because there's something in there that everybody expects you to know. No, we have no agenda with regard to types of calculation that you need to be comfortable with. What we really want you to focus on is when you have a problem, what strategies can you employ to solve it? And the book that we've selected, or that I've selected, is focused exactly on that. Um, how can you think to solve a problem better? How do you approach a problem? How do you break it down? Uh, I'll try to provide some examples of that too, just to help you understand here at the start of the class. But that's what the book is for. It's just changing the way that you think about things so that you can figure out how to solve a problem, as opposed to like we do in class, where you read the lesson, they, they give you a very formulated way of doing it, you follow that procedure on a selection of problems similar to what the lesson set you up for, like T-ball, and we make you jump through a bunch of hoops to prove that you can do what the lesson covered. This is not that. With this program, you'll be given a problem, maybe students in Algebra 2 and students in college algebra, a few students from each of them, will all be given the same problem and may all have different ways of solving it. And in this course, I want you to be using a math journal to document all your approaches. I'm interested even in your false starts. Did you try to approach it one way? Did it work? And what this book will guide you through a selection of curated problems, is ways of specializing. So if I ask you a question, well, let's get specific. Let's work on a specific example of what that question may look like. Let's keep it simple at first. Come up with an easy example. Maybe one that we already know what the answer should be, but think through, okay, how would we have solved it if we didn't? And then go to a slightly more complicated version. After you do a few examples, do you start to notice patterns? A lot of this will be about what do you notice as you do various examples. And once you notice something, can you then generalize? So as you go through the book, some of the first pages, you'll be instructed on when you approach a problem, how do you first specialize special cases? And then from a variety of examples, can you then generalize to a general rule that helps you understand how to handle a problem of any specific example? That's really, it's an excellent book. It's a book that's used even for, I would say, PhD candidates for mathematics degrees, when they learn how to do math research. Well, sure, they were really good students up throughout schooling and then in college, but they just had to be good at performing and jumping through hoops, learning a trick, showing that they know how to use that trick, passing the test through a sequence of methods of calculations, through a sequence of topics. Then they get to working on their degree, and they need to come up with ways of solving problems that have never been solved before, or coming up with new math, and they may not know how to even get started. This book that we've selected does not involve or require, that's not to say you can't utilize stuff that you already know from more advanced classes, but it does not require you to be extremely familiar with a lot of math or a lot of hard math to approach these problems. It is training you on how to think. It's an excellent book. It is called Thinking Mathematically, written by John Mason and 2 other authors. We've ordered copies of this book, and so as they trickle in from various sellers, you'll be receiving your copy. I can print off pages of it until you get your own physical copy. I have grid notebooks as to be your math journals. I want you to keep your work in a single place, and so you can document your journey through each problem. Because the assessment isn't, I'm not going to ask you to jump through hoops or perform, demonstrate that you can have a high level of performance on different calculations. The assessment is going to be more presentation based. I want you to explain how you solve the problem and the whole journey of it. The nature of the presentations may get more advanced as the problems that you work on get more advanced. So at the beginning, maybe you'll turn something in, or maybe you'll record a little video for me and submit that, where you explain yourself, and visual aids will be encouraged. Showing me your notebook even, especially selections that you think are interesting in hindsight. A lot of this will be just reflecting on how you got through the problem. But I also want to, the assessment will be largely based on the communication and presentation of these ideas that you've worked on, these solutions. Two people may solve the same problem with entirely different ways of approaching it, or had completely different journeys in their path to solving the same problem. Other ways that you could present your solution is with a poster presentation. Might be nice to hang on the wall in the hallway so that people can walk by and check it out. But towards the end, I know I want to give you the experience of seminars, which are like short lectures to explain yourself verbally. You can have slides, posters, props to help you tell your story to your peers and maybe other faculty, not necessarily math experts, and explain the problem you were working on and how you did it, or even how you didn't do it, but how close you came and what you're still working on. What's giving you trouble, and these aren't just lectures where it's just you talking. Seminars more like an intimate setting where people can stop you, raise their hand, and you can stop in the middle of your talk and answer questions. You can take questions at the end. Nothing to be anxious about, but the communication is another big piece of this, and probably the major assessment that how you'll be judged. It won't be just, here's 10 questions. How many did you get right? Okay, I'll divide how many you got right by 10. That's not how we're going to assess you. You'll just need to work on the problems, show me that you're working on the problems, talk to me, I'll help talk you through it, and at the end, you're going to present what you've accomplished. I am going to be mindful of the workload. You will not, I understand that you already have your normal coursework, which is already, you're going to have near daily homework like you're used to already. And you'll have your quizzes where you are jumping through those hoops and asked to perform and measured on your performance. But this supplementary honors piece is not that. And I hope that this isn't too confusing. I hope that you're getting the gist of what I believe would be very enriching for you. And to just say one more time, the point of this is about training your thinking to solve problems, to elevate your thinking, and to encourage you to be more creative, more critical, and then to empower you going forward. That's what I believe an honor program should be, and that's what I believe we will have here. So I hope this isn't confusing. I'm recording this video hoping to explain what I believe will be a positive experience for you. I am excited and looking forward to this program developing. I hope you have some positive feelings about it too and are ready to get started. Um, Thank you for listening, and you guys have a great rest of your day. Take care.